Hi there, and welcome to this lesson on Pure Mathematics 2. And in this lesson, we're on Chapter 1 and 1.3, the Factor Theorem. Now, what is the Factor Theorem? Well, the Factor Theorem is a method that helps you to factorize polynomials into brackets. So let's say, for instance, you had this cubic, px cubed plus qx squared plus rx plus s, and you're going to factorize it into three brackets, x minus a times x minus b times x minus c, where you'd have to work out what a, b, and c are. But let's just consider for a moment what would happen if we put x equals a into this function. We could also think about x equals b or x equals c. You get exactly the same thing. But if we put x equals a into the function, then we get the value of the function when x equals a. And putting x equals a here, you'd get a minus b, and a minus c. And the first bracket's the significant one. A minus a is 0. So we get 0 times by these, and it doesn't matter what these are. If you times them by 0, you will get 0 for the answer. Now, what does that mean? Well, in other words, if x minus a is a factor of f of x, then f of a will equal 0. Or putting that the other way round, if f of a equals 0, and that means if we put x equals a into the function and we get 0 for the answer, then x minus a will be a factor of f of x. Now, this is what's called the factor theorem, and it's true for all functions. It helps you to find factors. Let's have a quick look at an example. And this example we'll do by two methods. First of all, we'll use the method that we learned in the last lesson, where we divide this by x minus 3 and see if it's a factor. And then after we've done that, we'll use the factor theorem to show how that works. But first of all, we'll do it by algebraic division, which hopefully you remember. You write down the cubic, and then you say that's going to equal x minus 3 times by something. And you've got to work out what the something is. And if it goes perfectly as a factor, then there won't be any remainder at the end. Okay, I'll let you have a go at doing this yourself first. So pause the video, have a go, and then come back again when you're ready. Okay, let's have a look. So if we're going to divide by x minus 3, we start off with the highest power, the x cubed, and we say x times by what would give me x cubed? Well, x times x squared gives me x cubed, so that's the x cubed term sorted. Then we look at the x squared term. We want minus 6x squared, but we've got minus 3 times x squared at the moment. So we've got minus 3x squared. We need another minus 3x squared if we're going to have minus 6x squared in total. To get another minus 3x squared, we need to have minus 3x here. And that times by the x will give me the other minus 3x squared. That's the x squared sorted. Then we look at the x's. We want 11x. We've got minus 3 times by minus 3x. So we've got plus 9x at the moment. We want 11x, so we need another 2x. The way we'll get those is if we have plus 2 here. And plus 2 times by the x will give me another 2x. And then last of all, you see if the number works. And if it does, you have got a factor. If it doesn't work, you haven't got a factor and you'll get a remainder. But in this case, 2 times minus 3 is minus 6, which means that x minus 3 is a factor of the cubic. So that's how you do the question using algebraic division. How would it work out if instead of that we tried to do the question using the factor theorem? Well, as you'll see, it's a great deal quicker. So if we want to show that x minus 3 is a factor of this cubic, all we have to do is find the value of f of 3, which means put 3 into the function and see what you get for the answer. If you get 0 for the answer, x minus 3 is a factor. If you don't get 0 for the answer, then it's not a factor. Okay, have a go at finishing the question yourself, pause the video, and come back to me when you're ready. Okay, let's have a look. It's very little that we have to do. All we have to do is find the value of f of 3, which means put 3 into the function for x. That'll give us 3 cubed minus 6 times 3 squared, plus 11 times 3 minus 6. You could just put all of that into the calculator. If you broke it down a bit, you'd get that. Pop that in the calculator, and you do get 0 for the answer. And the significance of getting 0 for the answer when we put 3 into the function is that x minus 3 is therefore a factor of the cubic. And that's the question done, a lot quicker than doing the division. So how do we use the factor theorem in general if we want to factorize a polynomial? Well, let's say, for example, that we had the cubic x cubed plus 3x squared minus 4x minus 12, and we want to factorize that into 3 brackets. What it means is that we're going to have to try and guess values of x, which will make this function equal 0. Well, how do we guess those values? Well, let's say you had 3 values, a, b, and c, and when you factorize the function, you got x plus a times x plus b times x plus c. The significant number in this function is the constant at the end. And whenever you're using the factor theorem, it's this number, the constant at the end, that you need to keep an eye on. Where does the minus 12 come from when we multiply out the brackets? Well, the minus 12 comes when we multiply the 3 constants together. So when we do a from this bracket times b from the second one times c from the third one, that's what gives us the minus 12. So minus 12 will equal a times b times c, which means that a, b, and c have to be factors of 12. So when we guess numbers and we hope to get 0 for the answer, we don't just guess any number. We need to guess numbers that are factors of 12. And I'd start off with the easiest numbers first. So 1 always works. So you try plus 1. You also need to try minus 1 and see if that works. Try plus 2, then try minus 2. Okay, let's have a look at a question and see how this works out. So that's the same cubic. We're going to try and factorize it using the factor theorem. If x minus a is a factor, then a will be a factor of 12. And as we said, that means you only need to try numbers that are factors of 12. So we'll try plus 1, then minus 1, plus 2, then minus 2. Now don't worry, you won't need to try all of these, but you're looking for 3 numbers that work. Once you've found 3 numbers that work, you've found all 3 factors. I'll let you have a go at finishing the question. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So we start with the easiest numbers first of all. So we try 1 and see if that works. If you put 1 into this, you get 1 plus 3 minus 4 minus 12, which gives you minus 12. That's not 0. Therefore, x minus 1 is not a factor of the function. Then try minus 1. If we put minus 1 in, we get minus 1 plus 3 plus 4 minus 12, which is minus 6. But again, that's not 0. So x plus 1 is also not a factor of the function. Then try plus 2. If we put in plus 2, we get 8 plus 12 minus 8 minus 12, which is exactly 0. And the significance of that is that therefore x minus 2 is a factor of the function. So that's one factor found. Then we'll try minus 2. If we put in minus 2, again, we get minus 8 plus 12 plus 8 minus 12, which is equal to 0. So x plus 2 is also a factor of the function. That's 2 factors found, 1 to go. Then we try 3. If we put in 3, we get 27 plus 27 minus 12, which is 30. It's not equal to 0. So therefore, x minus 3 is not a factor of the function. If we try minus 3, we do get 0 for the answer. So that's the third factor. X plus 3 is a factor of the function. So we found all 3 factors now, which means that f of x is equal to x minus 2 times x plus 2 times by x plus 3. Now, things get a little bit more complicated if the number of x cubes is not 1. So if we were thinking about a cubic, the last question had 1x cubed. If we had 2x cubed or 3x cubed, things get a little bit more tricky. And you could have a factor of the form some number times by x minus b. So let's say, for example, we had 2x cubed plus x squared minus 13x plus 6. Well, if we factorize that into 3 brackets, 2 of them are like we had on the last question, x minus 2 and x plus 3, but you get this one awkward bracket, 2x minus 1. Now, f of 2 equals 0 if we put x equals 2 in, because this second bracket will equal 0. f of minus 3 equals 0, because x equals minus 3 will make this last bracket equal 0. Now, what value of x will make this first bracket equal to 0? Well, it's not a whole number. If we put a half into this bracket, x equals a half, we'll get 2 times a half is 1, and 1 minus 1 is 0. So for these two brackets, it is just a whole number, which is a factor of 6 that works, but you get this third bracket, where a half is the number that would work. Now, in general, if the fraction b over a equals 0, if we put x equals b over a into the function, then ax minus b is a factor of the function. Now, the good news is, in practice, it's virtually never that you need to actually try putting fractions in and seeing if they work. Normally, all you need to do is find any whole number that works. And once you've found a whole number that works, you can then divide the cubic, like we did in the last lesson, by that factor. And you can simplify the question into having a linear factor and a quadratic factor that you will then factorize by normal methods for quadratics. Okay, let's just have a look at what that actually means in practice. So example 3, we've got a cubic equation, 6x cubed. The moment you see that 6 there in front of the x cubed, you know that at least one of the brackets is going to be awkward. But we've been told that x minus 3 works. We need to prove that it does. So you try x equals 3, show that equals 0. Once you've shown that it works, then divide the cubic by x minus 3 using the method that you learned in the last lesson. When you divide by x minus 3, you should get a quadratic for the quotient. And you then factorize the quadratic just by the normal method for factorizing quadratics. Okay, I'll see if you can make sense of all of that yourself, first of all. So 2 steps. First of all, just show that this is a factor of that by putting x equals 3 in. Then divide by that factor to get a quadratic, then factorize the quadratic. Have a go by yourself. Pause the video and come back to me when you're ready. Okay, let's have a look. So we need to put 3 into the function first of all to see if that works. So if we put 3 into the function, we get 6 times by 3 cubed, which is that, then minus 17 times 3 squared, minus 5 times 3 plus 6. Put all of that into the calculator, and you do get 0 for the answer. So that's all you need to do to prove that x minus 3 is a factor of this. Once you know that you have a factor, you can then divide by that factor to simplify the question. So 6x cubed minus 17x squared minus 5x plus 6 divided by x minus 3. So if we use the normal method, that's what you get for the answer in the second bracket. 6x squared plus x minus 2. Now what you do is you look at the quadratic, and you factorize the quadratic just by normal methods for factorizing. And that gives you 6x squared plus x minus 2 is equal to 2x minus 1 times by 3x plus 2. And you'll notice here that both of these factors have got a number in front of the x. So the whole thing factorized into 3 brackets will be x minus 3 times 2x minus 1 times by 3x plus 2. And just note the significance of these 3 brackets. The first one tells us that f of 3 will equal 0. If we put x equals 3, we'll get 0. And then the other 2 are the more awkward ones. F of a half will equal 0 from this second bracket, and f of minus 2/3 equals 0 from this third bracket. Okay, example 4. Using our answer to example 3, sketch the graph of the cubic. So that was the cubic. We factorized it into 3 brackets. Okay, have a go at just sketching what you think that cubic curve looks like. Now, when you sketch a curve, the general shape needs to be right. You don't need to do accurate axes. You don't need to use graph paper. But you should indicate, in this case, the crossing points on the x-axis and maybe the one on the y-axis as well. So just see if you can do a quick sketch of that cubic curve. Pause the video, come back when you've done it. Okay, let's have a look at this. Well, to sketch the curve, what we really want to know is the crossing points on the x-axis. That'll be the most important thing for this. Well, it crosses the x-axis when y equals 0 or when f of x equals 0. And that will happen from the first bracket when x equals 3, from the second bracket when x equals 1/2, and from the third bracket when x equals minus 2/3. And that means that the cubit will look something like this. So with a crossing point here at minus 2/3, one here at 1/2, one here at 3. And this crossing point on the y-axis here, which isn't labeled, that will be plus 6. You can just read that from the constant at the end. Okay, example 5. Given that x minus 1 is a factor of this quartic equation, 3x to the 4 minus 5x squared plus a, find the value of a. Now, this is a lot easier than it looks. If x minus 1 is a factor of that, that means if we put x equals 1 into that function, we should get 0 for the answer. That just gives you an equation in a very quickly. So all you have to do is put x equals 1 into that function, say that the answer is 0, and then work out the value of a. I'll let you see if you can make sense of that yourself. So pause the video and come back to me when you're ready. Okay, so we need to put x equals 1 into the function. And we know that when we put x equals 1 into the function, we'll get 0 for the answer, because we've been told that x minus 1 is a factor. Well, if we put 1 into the function, we'll get 3 times 1 to the power of 4 minus 5 times 1 squared plus a, and that has to equal 0. Tidying that up gives us 3 minus 5 plus a is 0, which means minus 2 plus a is 0, and a is equal to 2. And that's the answer. Example 6, very, very similar, just slightly harder numbers. Given that 2x minus 3 is a factor of f of x equals ax cubed minus 20x squared minus x plus 6, again find the value of a, and hence factorize f of x. Now this time, the value of x, which will make this bracket equal to 0, is x equals 3 over 2. So we'll need to put 3 over 2 into the function, say that the answer is 0, and then work out what a is, just like we did in the last question. Same method, just a bit more awkward because we have 3 over 2 for the value of x. Have a go at doing that, pause the video, and then come back to me when you're ready. Okay, let's have a look. So we're putting 3 over 2 into the function because x equals 3 over 2 will make this bracket equal to 0. And we know that the answer should be 0 when we do that. So a times by 3 over 2 cubed minus 20 times 3 over 2 squared minus 3 over 2 plus 6 has to equal 0 for the answer. When I cube this bracket and square this bracket, that's what I'll get. Tidying things up a little bit more, multiplying out this bracket and this one will give me that. And I've also moved these to the other side of the equal sign, which is why the signs have changed. And then it simplifies to that. And finally, a will equal 81 over 2 times by 8 over 27, which gives us a equals 12 for the answer. Which means that f of x is equal to 12x cubed minus 20x squared minus x plus 6 when we substitute in a equals 12. Now we were also asked to factorize the function. So we now know that f of x is equal to 12x cubed minus 20x squared because we worked out that a was equal to 12. We know that 2x minus 3 is a factor, so we can divide by 2x minus 3. When we divide by 2x minus 3, same method as the last lesson, we want to get 12x cubed. 2x times by 6x squared will give me 12x cubed. Looking at the x squared, I've got minus 18x squared when I multiply those together. I want minus 20, so I need to lose another 2x squared. To get minus 2x squared, I just need minus x here. Multiply that by the 2x and it'll give me minus 2x squared. That's the x squared sorted. Looking at the x's, I want minus 1x. When I do minus 3 times minus x, that'll give me plus 3x. So I need to take away 4x. To take away 4x, I'll need minus 2 here. And then minus 2 times by the 2x gives me minus 4x. And then last of all, I just need to make sure that the constant at the end works. I want plus 6. And when I do minus 3 times minus 2, I get plus 6. So no mistakes, 2x minus 3 is a factor. And then this quadratic is it's the quotient, it's the other factor. And we just need to factorize that in the normal way. Well, factorizing that gives us 3x minus 2 times 2x plus 1. Then we know all three factors. And we can say that the cubic is equal to 2x minus 3 times 3x minus 2 times by 2x plus 1. Okay, that does get us to the end of the lesson. If you've got the textbook, then turn to page 10 and have a go at exercise 1C. Thanks very much for listening, and cheerio.